Hello, everyone. Mr. Minnick's my name. Math is my game. It's Monday. We had a snow day over the weekend. That was a good time. Um, so here we are, 4 days later, something like that, looking at subtracting and adding rational expressions. What I saw on some of the homeworks that I looked over, some people had the right idea, some people didn't. In this video, not only will we be looking at this, but we also have a quiz in my Algebra 2 class tomorrow, and we're going to try to revisit some exponent rules. So without further ado, here goes number 4. The denominators are the same, so the numerators can simply be subtracted. We get x minus 4. That's over 16x squared, and that's it. That's all there is to do on number 4. There's nothing else that can be done. If, and this is a big if you split it up into x over 16x squared minus 4 over 16x squared, you're right back where you started. So there's really nothing else to do on number 4. You can't cancel anything because not all terms have like factors. Yes, x and 16x squared share an x. Okay, but number 4, x minus 4 over 16x squared, that's it. That's the answer. That's all there is to it. Now, number 8, some people started this off the right way. And if this were a test question, I would probably mark off 2 points and write and then. Because a lot of people have this, and they stopped. I saw a couple people try to cancel this minus 1 with this minus 1. Well, those are being added or subtracted, and you can't cancel them like that. And if you did cancel those, then you would be able to reduce the 4x squared and the 2x, and that would just be 2x, but that's not the answer. You can't cancel like that. We'd hopefully remember that from 8.4. But what you can do and what you should do from this point is factor the numerator into 2x plus 1 and 2x minus 1. And the denominator is still 2x minus 1. So the 2x minus 1 factors cancel. And so number 8, your final answer on number 8 should have been just 2x plus 1. Okay. So number 8, final answer, just 2x plus 1. Factor cancel. All that stuff from 8.4 comes back in 8.5. They didn't say anything about stating restrictions, so we won't worry about that. So far, so good? Cool. Well, before we move on to the next set, we might as well look at one exponent rule. Everybody knows that equals what it equals. You can punch it into the calculator, and the calculator will tell you what that equals. What does that equal, by the way? 1. But can anybody explain to me why? It's a test question. You'll have to figure it out. I explained it in class when I was talking about my college professor. You remember? Oh, you're saying, isn't it because it multiplies by itself? You got the right idea, just one word wrong. It's because you end up dividing something by itself. Yeah, if you think about your exponent rules, if you had something like 8 to the 7th over 8 to the 5th, that's 8 to the 7 minus 5. Well, in the case of 8 to the 0, that might be having something like 8 to the 7th over 8 to the 7th, which would be like 8 to the 7 minus 7. Whoops, 7 minus 7. And you know when you divide something by itself, you get 1. So that's why, because you're dividing something by itself. Good job memorizing that. All right, finding LCMs. I don't think anybody had this right from the papers I was looking at. Some people had the right idea. We got 2 different expressions. This 24x squared. 24, that's 2 times 2 times 2 times 3, and then x squared is, of course, x times x. So that other expression that we're looking at, we could factor an 8x out of that. So that's 8x times x minus 2. And if we broke 8 down further, that's 2 times 2 times 2 times x minus 2. So when we go to find the LCM of that, we have to represent everything that's there. Everything that's in each 1. Everything that's in each of these expressions, everything that's in this expression and everything that's in this expression, without representing too much. But we do have to represent everything that's in each one. That being said, we're going to have a 2 and a 2 and a 2. That takes care of these 3 2s, takes care of these 3 2s. What else do we need? Got to have more than an x. How about x times x, right? Because the 1 has 2 of them in it. So when we take care of those 2, that also takes care of this 1. What else do we got to have in it? An x minus 2 in it, and there's one more thing that's missing that's there that we didn't represent yet. There's a 3 also. So if we were to multiply all that stuff out, 2 times 2 times 2 times 3, that's back to 24x squared. So 24x squared times x minus 2, that's our LCM. That's our LCM. The LCM is going to at least be as big as the biggest expression you're looking at. The LCM of 40 and 100 is going to at least be as big as 100. How do we feel about LCMs? Question. So the question is, how come there was 2 x's in the one and the other one only had 1, but we have to have 2? So the deal is, when we look at this one, this has 2 x's in it. This one only has 1. You have to represent as much as is in each one. The one on the left has 2 in it. We have to represent 2 in our final answer. Let's look at something like this. Let's look at something like 100xy z squared and 400 and 40 a b x z cubed. Okay, if we looked at something like this, first of all, we'd have to find the LCM of 140. What would that be? 400, 200, 200. So 200. So now we see an x here and we see an x here. So as far as the x's go, what do we got to have? We got to have an x. Now this over here has a y in it, but the other one doesn't. But we do need to represent the y. So guess what the LCM is going to have in it? A y. Okay. The expression on the right has a b in it. And for that matter, has an a in it. Well, the one on the left doesn't. But we have to represent everything that's there. So guess what else is going to be on our LCM? An a and a b. Now, as far as the z's are concerned, the one on the left only has z squared. The one on the right has z cubed. We got to have that z cubed represented. We got to have z cubed because remember, the LCM is going to at least be as big as the biggest one. Does that help clear that up a little bit? Okay, cool. Cool beans. Very, very difficult concept to understand and to explain. There we go. All right. So exponent rules. Let's take another trip down memory lane. Speaking of raising something to the 0th power, if you had to write that on a word processor, it's written this way. To me, that looks like an owl. Can you see it? Can you see an owl there? You don't see the owl? Speaking of owls, knock, knock. Owls. I know. So there's a question on the quiz about this. What are the 3 possibilities for this? What are the 3 possibilities for this? Now, a few minutes ago, we said anytime you raise something to the 0 power, it's like dividing it by itself. So what happens if you divide something by itself? You get 1. Well, what happens if you divide 0 by something? If you divide 0 by something, what do you get? 0. And what happens if you divide something? If you divide something by 0, what do you get? Undefined, undefined, undefined. Okay. 3 possible outcomes for the owl. Who? No, 3 possible outcomes for the owl. All right. Well, moving right along, unlike denominators, we'll certainly see some of these on tomorrow's quiz. The denominators are real similar. Whatever you do, don't ever do this. Don't ever say, well, we add x here and we add x here. Bless you. We don't ever add x and add x. That doesn't work like that. We want our denominators to look identical, so what we need to do is find the LCM of 5x and 6x. And we know it's going to have an x in it. So I guess now we got to find the LCM of 5 and 6. What is it? 30. So our LCM's 30x. So we want our denominator to look like that, 30x. So what we're going to have to do on number 16, let me see if I can get my white marker going here, cover up that 16. What I'm going to have to do is I'm going to have to multiply each fraction by something over something, which is really like multiplying it by 1. The one on the left, what do I multiply by? 6 over, not over 1, 6 over 6, right? Because 6 over 6 is like multiplying it by 1, which doesn't change it. What do I multiply the other fraction by? 5 over 5. Cool. So when I do that then, 6 times 12 is 72. I get 72 over 30x plus 35 over 30x. And now it's just like number 4 was. 72 plus 35, is that 107? So we get 107 over 30x. And that's it. That's your answer to number 16. I think I saw a couple people who had that. Nice job in getting that one. These really aren't that bad as long as you can treat them like fractions instead of freaking out because there's polynomials there. They're really not that bad. Question. The LCM is what the denominator is going to look like. Yeah, the LCD is what the denominators are going to look like, and it's the LCM of those two. Yep. So let me go ahead and cover up that one, and we'll look at number 20 next. So on number 20, same kind of thing. Whenever we find our LCM, we got to represent everything that's there. So our LCM or our LCD, I guess, is going to be x plus 4 times x plus 6, right? Because we got to represent everything that's there. So what we're going to have to do is multiply the fraction on the right by something over something and the fraction on the left by something over something. So the one on the left, what do we multiply it by? X plus 6 over x plus 6. And on the one on the right, what do we multiply it by? X plus 4 over x plus 4. All right. So here's where we need to use the distributive property. 3 times x, of course, is 3x. 3 times 6 is 18. So we get 3x plus 18. Here we're going to have just x plus 4. But we are subtracting that whole quantity. Why are you subtracting x? We are subtracting 4. So what we're going to get here, our denominator is going to be this x plus 4 times x plus 6. It doesn't matter what order you write that in. So we're going to have this 3x take away that 1x. So what's that going to be? 2x. Then we have 18 take away 4. 18 take away 4. So that's going to be 14. And there's one more thing that we could do. It's not really going to help us, but one more thing we could do. What could you do to that numerator? Since both terms are even. You could divide by 2. So you could have 2 times x plus 7 all over x plus 4 times x plus 6. And that would be the best final answer. If you just left it 2x plus 14 over x plus 4 times x plus 6, that's all right too. It's all right also. So that one was a little bit more challenging, but certainly not that bad. Did we kind of get a feel for what's going on with adding and subtracting to get like denominators? You know why we're doing that? When we get into the next section, here's a sneak peek into the future. In the next section, we're going to have something like 2x over x plus 3 plus 5 over x equals 6 over x squared minus 9, and we're going to be asked to solve. And it's really not that bad, but the deal is, ideally, we want a proportion. A proportion. We want something over something equals something over something. Do we have a proportion yet to start with? If you look at this doesn't really meet the criterion of a proportion, does it? But we can do stuff that we're learning in this section and put those two terms together and get a proportion pretty quickly, huh? And once we get proportions, then we can do what we need to do. So like I've been saying all along, the stuff from the last section it's imperative that you understand it when we move on to the next one. Okay. So all right. So 28. Wow. This looks like fun. So what I would do on one like 28, which not many people tried, a couple of people did, on 28 you're going to factor. You're going to factor. So the x plus 3 really can't factor. The denominator here, though, this can factor. That's going to be x minus 4 and x plus 2. Minus the x minus 5, nothing really happens to that. But the denominator, that x squared minus 12x plus 32, that's going to factor into x minus 4 and x minus 8. So our denominators have to be identical. So our LCD, it looks to me like it's going to have an x minus 4 in it. It's going to have an x minus 8 in it. And it's also going to need that x plus 2 in it. So just like we did to the last one, we're going to have to multiply this fraction by something over something. X minus 8 over x minus 8. And we're going to have to multiply this other fraction by something over something. What's that going to be? What's that other one going to need that it doesn't have? The x plus 2 over x plus 2, right? Okay. All right. So now we can use the distributive property. I'm really good at FOILing. I'm going to skip a couple steps here, not too many. X times x is x squared. I'm going to have minus 8x plus 3x, so that's going to be minus 5x. Minus 8 times 3, that's minus 24. X times x is, of course, x squared. Minus 5x plus 2x, that's minus 3x. And minus 5 times 2, that's minus 10. So I am subtracting that whole quantity. So let's see. What happens if I take x squared minus x squared? What's that leave? Nothing. So then I have minus 5x minus minus 3x. Minus 5x minus minus 3x. So how many x's is that going to leave? It's going to be minus 2x. And I have minus 24 minus minus 10. That's minus 14. The denominator we said was this x minus 4 times x minus 8 times x plus 2. And just like the last one, we could factor a negative 2 out. Well, the last one we just factored a 2 out, but we could factor a negative 2 out. That's an x plus 7. Doesn't really help us any, but we could factor it out. And so that's the best answer on that one. I know what you're thinking. You're thinking, boy, these aren't fun at all. And you're right. They take up a lot of space. They really do. This is kind of like going to the laundromat with your laundry and your wife's laundry and your dog's laundry. Anybody's dog have laundry? My dog likes pillows. I don't know what his obsession is, but he has a couple pillows and he just like chews on them. It's weird. He's like, who was that from Charlie Brown? Was that Linus that carried the blanket? My dog's like that with a pillow. He'll go up and down our stairway. It's pretty high, and he'll carry this big pillow up and down the stairs. He's a lab pit mix. Lab pit mix. Good dog. All right, so at some point we looked at exponent rules, and we said that if you have something like x to the m divided by n power, that something weird happens here. That you end up introducing something that's unusual. You end up introducing radicals. And what happens is the denominator is the index of the radical. And what also ends up happening is the numerator ends up being the power. And this could be written as the nth root of x to the m like that also. So there might be a question on the quiz that asks you to rewrite might ask you to rewrite something like this. I don't know. 6 to the 1/2 power. If you had to write 6 to the 1/2 power, that would be the square root of 6 to the first, or just the square root of 6. You really, that 2 that's in there really doesn't need to be written if it's a square root. So something like that. And we're going to be into chapter 6 before you know it, and we're going to see all kind of those things in chapter 6. Matter of fact, in chapter 6, we're going to be simplifying something like the cubed root of 81 x to the 5th, y to the 6th. And that kind of reminds me of 70 degrees and sunny in Newton Falls. Actually, 70 degrees and partly sunny in Newton Falls is what it reminds me of. Anybody ever been to Newton Falls on a partly sunny day? Newton Falls likes their basketball, and maybe today's a bad day to talk about that. Because didn't our girls' team get beat by Newton Falls last week? Anyway, in Newton Falls, they really like their basketball. If we look at this 81, 81 is the same thing as 27 times 3. And if I look at x to the 5th is really the same thing as x to the 3rd times x squared. And if I look at y to the 6th is really the same thing as y cubed, y cubed. So what I'm trying to tell you is I'll be using this metaphor about 70 and partly cloudy in Newton Falls. Some people go outside and play basketball. Some people don't. But anyway, the 3rd root of 27, that's a perfect cube, and a 3 pops out because of that. The 3rd root of x to the 3rd, that's a perfect root, and because of that, an x pops out of that. And because we have a 3rd root of y cubed and y cubed, that means we're going to have a y and a y pop out. Or if you'd rather write it this way, a y squared pop out like that. So those are all the people out playing basketball. Under the 3rd root then would still be this 3 here and this x squared here. And that's what we're going to be doing in chapter 6. Yeah. So that's coming. 32. These are the ones. There is one just like this on the test, on the quiz. On this, you have to look at the LCM of the denominators. So if we're looking at x and 5, it's 5x. So we multiply by 5x over 5x. So what ends up happening is we've got 15 times 5x, which gives us 75x. Now, this other term right here, what's going on there is we're going to be taking negative 2 over x and multiplying it by 5x. Can you see anything that might cross-cancel in that? Can you see that this x is going to cross-cancel that x? So what's left? Minus 2 times 5. What's that? That's going to be minus 10. That's going to be minus 10. So that takes care of the numerator. And the cool thing is this little trick gets rid of all the fractions in both the numerator and the denominator, which we still have a fraction overall, but we get rid of the fractions in the numerator and denominator. So up first then, right here, I have x over 5, and I'm multiplying that by 5x. So does anything there cancel? The 5s. The 5 cancels the 5. So what that's going to leave then is x times x, or x squared. And then we have this 5x times 4. What's that? 20x. Good. So that's 20x. So it's always best to try to factor because maybe something might cancel. So if we factored this, 75 and 10 are both divisible by 5. That's 5 times 15x minus 2. In the denominator, we could factor an x out. And nothing really cancels, so that's the best we can do. And that's okay. So far, so good? All right. So on that quiz, I really want you to have a chance to do as well as you can on that quiz. There's not going to be one as bad as 36 on it, I don't think. But there is going to be something like this. There's going to be one like this. There's actually going to be two like this. And I really want you to understand something. I really want you to understand that 2 minus x is not the same thing as x minus 2. A lot of people think that they're the same thing. They're not. What 2 minus x is, it's the same thing as the opposite of x plus 2. Because if you took 2 minus x and you rewrote it, it'd be negative x plus 2. And if you factored a negative 1 out, then it would be x. Oh, wait a minute. Did I just mess that up? It would be negative x plus 2, so it's negative 1 times x minus 2. Ooh. So it's the opposite of x minus 2. Okay. Real important idea. There's going to be two questions on the quiz that utilize this fact. Okay. So what should I rewrite this 2 minus x as then? What should I rewrite that as? Negative the group of x minus 2. Okay. So that's over 15x. Big fraction. 45x cubed. Could I factor something out of this? Is there anything I could factor out of that? On x, good. So then that's going to leave behind x squared minus 4. So that's actually going to factor further because that's a difference of two squares. So I still got the negative. I still got the x minus 2. Still got the 45x cubed. The bottom is 15x squared. And this is a difference of two squares, so that's going to factor into x plus 2 and x minus 2. So now let's see what cancels, if anything. So the answer is going to be negative. So our final answer is going to be negative something. Well, let's see. Are there any factors top and bottom that are going to cancel or cross cancel? X minus 2's. What about 15 and 45? They're both divisible by 15, aren't they? So the 15 is going to turn into a 1. The 45 is going to turn into a 3. And then think of your exponent rules. What's going to happen with the x's? We have xxx up top and xx in the bottom. So what are we going to end up with? How many x's and where? 1x in the top. Good. So we're going to have a 3 up top. We're going to have an x up top. What's left? x plus 2 in the bottom, and then that's it. The negative sign can either go out front or in the top. If it went in the bottom, you'd need parentheses in front of that x plus 2. So negative sign, it's probably the best idea to just put it out front like that. Think you can handle a couple of those like that on tomorrow's quiz? There's 2 of them just like that. Just like that. Okay. Well, the last problem in this homework, last time I did this, I messed it up. And I think it takes about a whole page of notebook paper, but that's okay. Do you want to see this one worked out? Okay. I'll try my bestest not to screw it up. So we got a factor. So the numerator ends up being 1 over 3 times x plus 1 times x minus 1. That's the whole numerator. The denominator ends up being 5 over x plus 1 minus x plus 4 over x minus 4 times x plus 1. So it's kind of neat that every single denominator has an x plus 1 in it. So when I'm pre-planning this and I'm thinking about my LCD is going to have an x plus 1 in it. Let's see how good we are at finding LCDs. What else does it got to have in it? An x minus 1. What else does it have to have in it? An x minus 4, and there's one more thing. Not x plus. We already got x plus 1. We already got the x minus 1. We already got the x minus 4. One more thing. 3. Good. So we're going to have to multiply both the numerator and the denominator by that over itself. So we're going to multiply by 3 times x plus 1 times x minus 1 times x. Whoop. I said x minus 1 and wrote x minus 4. And x minus 4 all over 3 times x plus 1 times x minus 1 times x minus 4. So up top, what's cool is the 3 is going to cancel the 3. The x plus 1 is going to cancel the x plus 1. The x minus 1 is going to cancel the x minus 1. And up top, all we got is 1 times x minus 4. And 1 times x minus 4 is just x minus 4. So that's my numerator. The left part of my denominator, this part, what I'm going to have is 5 over x plus 1 times 3 times x plus 1 times x minus 1 times x minus 4. Big fraction, the x plus 1's cancel. So I'm going to have 15 times x squared minus 5x plus 4. So I'm going to get out of that, just in this bottom left, 15x squared minus 75x plus 60. In the bottom right, I have negative x plus 4 over x minus 4 times x plus 1. I'm going to be multiplying that by 3 times x plus 1 times x minus 1 times x minus 4. So the x minus 4's cancel. The x plus 1's cancel. Oh, man. So I got x plus 4 times x minus 1, which is going to be x squared plus 3x minus 4. And I'll be multiplying all that by negative 3. So that's going to be... Maybe I'll just forget about the negative for a minute. And say I'm subtracting all this. But I am going to multiply by 3. So that's 3x squared plus 9x minus 12, right? Okay. And I am subtracting all that. Wow. So I got x minus 4 up top. In the bottom, I'm going to have 12x squared Minus 75 minus 9 is going to be minus 84x. 60 minus 12 is plus 72. I got x minus 4 over 12 times x squared minus, oh gosh, how many times does 12 go into 84? Is that 8, 7, 6, 7? 7. So that's minus 7x plus 6. Whoa, this is going to factor. This is going to factor, so that's x minus 4 over 12 times x minus 1 times x minus 6. That's it. Wow. The TI Inspired Cast will do that. So, exponent rules. Make sure you know your exponent rules. Make sure you know why something divided by, or why something raised to the 0 power is 1. Make sure you know that 3 minus x is the same thing as the opposite of x minus 3. And I guess that's all I got to say, unless there's any shout-outs. I'll give a shout-out to the snow day. Shout-out to the future Mr. Minnick. Probably doing next week's lesson plans. Well, it's been real. It's been fun. Have a great day. See you. Good.